Hello everyone, welcome to this video. In this video, we are going to learn about Kernel Ridge Regression using OpenMathAI. So, let's get started. What is Kernel Ridge Regression? Kernel Ridge Regression is a supervised machine learning algorithm used for regression problems. It combines ridge regression with a kernel trick to learn both linear and nonlinear relationships. Unlike linear regression and ridge regression, which mainly learn linear patterns, Kernel Ridge Regression uses kernel functions, such as the RBF kernel, to model complex nonlinear relationships while reducing overfitting through regularization. Kernel Ridge Regression starts by computing the similarity between training samples using the selected kernel function. It then builds a kernel matrix and learns a model by solving a regularized optimization problem. During prediction, the new input is compared with the training samples through the kernel function, allowing the model to accurately estimate nonlinear outputs. Imagine we want to predict the pressure distribution over an aircraft airfoil. Instead of assuming a simple linear relationship, Kernel Ridge Regression learns a nonlinear relationship between the airfoil geometry, operating conditions, and aerodynamic behavior. This enables a model to accurately predict pressure and other aerodynamic properties for new operating conditions. We will use an airfoil aerodynamics dataset for the Kernel Ridge Regression model. This dataset contains 1,000 data samples representing the aerodynamic behavior of an airfoil. During training, Kernel Ridge Regression learns a nonlinear relationship between the input features and the aerodynamic output, enabling accurate prediction for unseen operating conditions. So, let's get started. OpenMathAI. In this demonstration, we're using airfoil aerodynamics using kernel model. Click Create New Project. Enter the project name as Airfoil Prediction. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There is also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There is one more feature, Signal Diagnostics. There is 3 columns. First one is column its tell which features on the dataset like inputs and outputs name. Second one is VI if it tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the Kernel Ridge model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R squared equals 0.95 accuracy, almost equal to 95%. Click Fit to Window. You will see three types. Fit to Window, comfortable, compact. Then the clear history. If you click that, it will clear the history before its trained model. Another is deselect and select all trained models for export. Click View Curves. You will see the diagram of R squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation and source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. ANSYS, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.